We've already talked about graphing sine and cosine graphs in 14.1a and b. Today we're doing the exact same thing, except we're going to translate those graphs to the left or right, so horizontal shift, or up and down to find a vertical shift. So in order to do this, we're still going to have the graphs y equals a sine b x, like we're used to. However, we're going to change it a little bit with the minus h and the plus k. Remember, the minus h is always the horizontal shift, so left and right, and it's going to be opposite. And the plus k is always going to be up or down, and that's going to be not opposite. It's just going to be whatever it says. So it's exactly the same as what we did before. In step 1, we're going to find the amplitude a, the period 2 pi over b, the horizontal shift h, and the vertical shift k of the graph. We define these 4 things. Step 2 is going to be draw the horizontal line y equals k. So whatever the vertical shift is, we're going to draw a line through the graph. That's called the midline of the graph. Step 3 is going to find the 5 key points. Remember, for sine, those 5 key points are actually different from cosine, and I'll get into that again later. And step 4 is just going to be draw the graph through the points that you already found. For the graph y equals 2 sine 4x plus 3, we need to, in step 1, find the amplitude, which is 2, the period, which is 2 pi divided by b. In this case, b is 4. So the period is pi over 2. That means that the one entire cycle of the graph will be fit between 0 and pi over 2. We need to find the horizontal shift. In this case, there's no minus h, so the horizontal shift doesn't exist. It's just 0. And the vertical shift, the plus k is actually here, so where the vertical shift is going to be plus 3. So k equals 3. That's the vertical shift. That's step 1. Step 2 is going to be draw the midline through the graph. So we know the vertical shift is plus 3. So plus 3 is actually going to be the midline of this graph. There's going to be stuff above and below it. However, the midline is plus 3. So y equals sine x goes through the x-axis, but this graph is going to go through this line, y equals k, or y equals 3. Step 3 is going to be to find the key points. Remember, for sine, those key points, how to find them, are in 14.1a, so I'll just review that here. The first point is just 0, 0. However, since we have a vertical shift of 3, every single point that we find will be moved up 3 on the y-axis so that it intersects this new line. So the first point is actually 0, 3, which is right here. The second x-intercept is going to be found by 1/2 times the period. In this case, the period is pi over 2. And it would be 0, but because we have a plus 3, we're going to do 0 plus 3. So that point is equal to pi over 4, 3. That's the second time that it intersects the axis. Pi over 4, 3. The third x-intercept is going to be the period, so it's just going to be pi over 2, 0 plus 3, because remember, everything is moved up 3 in the y-axis. So pi over 2 and 3. Those are going to be the 3 x-intercepts, and we found 3 x-intercepts because this is a sine graph. I need to make some space here, so I'm going to erase how I found my new intercepts. Because for the sine graph, we need to find one maximum, and from 14.1a, you know to find the maximum is 1/4 times the period, which is pi over 2, comma, amplitude, which in this case is 2, but we need to move it up 3. So we have pi over 8, 5, that's the maximum. So this is pi over 8 plus 5, And we need to find the minimum. To find the minimum, once again, from 14.1a, you're going to do 3/4 times the period, pi over 2, comma, negative amplitude, so -2 plus 3, because 3 is the vertical shift, and we're going to get 3 pi over 8, 1. So 3 pi over 8, go up 1 and put a dot. And then the last step is just going to be drawing our line through the points. And this is what this new sine graph will look like. My second example is of a horizontal shift, but this time looking at a cosine graph. So the first step is still going to be finding the amplitude, which is 5, the period, which is 2 pi over b, and b in this case is going to be 2, because there's a b in front of the x term, so the b is going to be 2. The period is just pi. It will complete a whole cycle in the distance of pi. The horizontal shift is what we care about this time, because there's a minus h here. So because of the minus 3 pi, the horizontal shift is going to be 3 pi to the right. Remember, it's opposite. Vertical shift, there's no plus or minus k over here. Horizontal shift is going to be nothing. That's step 1. Step 2 is going to be draw the midline of the graph. And remember, the midline is equal to the vertical shift. So here there's no midline. It's just going to be the x-axis like it normally is. So step 2 is already done for us. Step 3 is going to be finding the 5 key points. For cosine, the 5 key points are different from sine. There are 2 intercepts. The first intercept is found by 1/4 times the period, which is pi, plus h, comma 0. So here we have pi over h, or pi over 4, plus h, which is 3 pi, comma 0. We can't add those two together because they don't have a common denominator, so we're going to multiply this one by 4 over 4. So it's going to be pi plus 12 pi over 4, which is going to be 13 pi over 4, comma 0. That's one of the x-intercepts. Because normally the x-intercept would just be this first part, 1/4 times the period, pi over 4. But because we have a horizontal shift, we have to add the h to the x component, because x is the horizontal axis. So we're going to move it 3 pi to the right. The new intercept is 13 pi over 4. We have one more x-intercept, and that's going to be, according to 14.1b, the new x-intercept for the second intercept is 3/4 times the period times pi, comma 0, but of course because we have a horizontal shift we have to add h. So we have 3 pi over 4 plus 3 pi, comma 0. And the comma 0 is to remind you, it is an intercept. That would be different if the vertical shift was there, but because there's no vertical shift, it's just still going to be going through 0. And so our new one is, we have to multiply this by 4 over 4, so we can add it, 3 plus 12, so 15 pi over 4, comma 0. And those are our 2 points on the x-axis where it's going to cross the graph. I moved the 2 x-intercepts up here so I could make some space to find the other 3 key points. So now we need, for our cosine function, 2 maximums. So to find the maximums, the first one is normally going to be 0, comma a. But because we have a horizontal shift, it's 0 plus our horizontal shift, comma a, which is 0 plus 3 pi, so 3 pi, comma a, which is 5. Our first maximum is at 3 pi, comma 5. our second maximum is going to be, normally, our second maximum is going to be the period, comma a, so 2 pi over b, that's the period, comma a. So in this case, what we should have is pi, because the period is pi, comma a, but because we have the horizontal shift, we need pi plus 3 pi, that's the period, that's the horizontal shift, comma a. So we're going to have 4 pi, comma 5. So the second maximum is at 4 pi, comma 5. Last step is going to be to find the minimum, and the equation for the minimum is 1/2 times the period, so 1/2 pi, plus the horizontal shift, because we do have a horizontal shift, comma negative amplitude, so negative a. That means we have 1/2 pi plus 3 pi, comma negative 5. I'm just plugging in points from number 1, where I got all the 4 points. So we have 1/2 pi plus 3 pi. 3 pi is the same as 6 pi over 2. And we make those denominators the same. So we get 7 pi over 2, comma negative 5. And that's our minimum. Now, once we have all of these points, we can go ahead and draw our graph. I'm actually going to extend this graph out here a little bit because it looks like we're going to need some more space. Because our points are here and these 4, all the way over here. So if this is pi, and this is pi over 2, 3 pi over 2, 2 pi. We haven't even hit our first point yet. We have 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, and that might be enough points. Yeah, I think that's enough points. So our first point is going to be, it doesn't really matter what the first point is, we just start plugging them in. So we have 7 pi over 2, comma negative 5, 7 pi over 2, comma negative 5, we have a point here, check that one off, 3 pi, comma 5, so 3 pi and then go up to 5, that's one of our maxes, so that makes sense. Then we need 13 pi over 4, comma 0, so 13 pi over 4, that's a little bit more than 3 pi, because 12 pi over 4 would be 3 pi. So our x-intercept is going to be somewhere like right here. Then we have another max, 4 pi, comma 5. And an x-intercept, 15 pi over 4, that's almost 4 pi. Not quite there, so it's like right here. So if I'm to draw a graph through these points, it would be something like this, all the way over here. But of course, as you know, this graph keeps going on like this the whole time. So we can extend it out like that if we know the relationship for a single cycle. If we know the relationship for a single cycle, we can extend it so it looks the same going on the left and the right.